How does this work? With function comes domain and it comes range, correct? So when I talk about function of two variables, let me write my notes right here. F goes from R2, oh, sorry, my bad handwriting. F goes from a subset of R2 to R. So you choose a subset of R2, you choose a subset of plane, and F acts on that. That D is the domain. What is domain? Every input that you can put in. Okay? So what does this do? F acts on a point on R2. What is point in R2? X and Y. Then it spits out a number that is just a real number. Function of two variables. That's the function of two variables. Now I want to define the range of this thing. Range of this thing, so the domain is the set that F acts on. Domain is set of all inputs. Write down all inputs. Range is all the outputs. Range, the set of all outputs. How do I show it? For showing it, am I writing big enough? Can you guys see it? Okay, thank you. And so to show it, you write this way. Z equal to f of x and y such that x and y is, do you guys know this means in the domain. If you haven't seen it, it's a good time to learn it. That sometimes people call it epsilon, sometimes call it the lowercase epsilon. It means in. Means this point is in the domain. So that's the range. It's just everything set of all the outputs that you're putting in. So all the outputs gives you a Z. Okay, let's do some examples. Now, one thing I want to say that I didn't say right now, these two are independent variables. That one is the dependent. Variable. So, function of one variable, y equal to f of x. Which one is independent? X. Which one is dependent? Y. Which one is input? X. Which one is output? Y. When I go to function of two variables, independents are x and y, and then dependents are z. Then the independents are input, their output is z, right? So that's how it goes. If this goes here, oh no, my example's right there. Let me do an example, upside down example. Okay, so in here, let me think about this. Z equal to f of x and y. F of x and y is square root of x squared plus y squared minus 1. Give me a point that I can plug into this. Point in R2. You guys give me a point. 3 and 2. So what is f of 3 and 2? Let's see if it works. X to power 2 plus y to power 2. Why am I having that 2 over there? Minus 1, square root of 12. So this function, if I plug in 3 and 2, it gives me square root of 12. Now you guys tell me, What values can I not plug in? Oh, 0 and 0. Can I plug in 0 and 0? No. That's bad. Let's do that. Okay. So can you tell me exactly the sets that I cannot plug in? Set of points that I cannot plug in. Anything, the set that makes this part negative. So opposite of that is the set that makes this part positive or equal to 0 is okay. Fair game? So domain is everything that makes x squared plus y squared minus 1 bigger than or equal to 0. Okay. If you watch the pre-lecture, it tells you the inequality in pre-calculus when we did inequality. But let me remind you, this inequality, if I want to draw the solution to this inequality, I first of all set it as equal. If I set this as equal, what do I get? I get a circle. Circle is included. So I draw this circle of radius 1. This is 1. Then use test points. For test either inside the circle or outside the circle. What is a good test point inside the circle? 0, 0. Does 0, 0 satisfy the inequality? No. You can test another point, let's say 2 and 0. That is outside. And it would satisfy. So the outside is the answer. So I use the inequality to find the boundary. To find boundary. I use the equality. Then I use a test point. And test point 0, 0 didn't work, so it's the other region. Boundary divided the entire space into two pieces. Imagining these things are kind of important, and I'm trying to, I was just talking to my daughter, and she said, everything that I do, and she's an engineering, a graduate student, and she said, everything that I do has to do with imagining how the space is divided. And it's so true. If you want to get further in, everything is about imagination. We give you a lot of possibility to do that in Calc 3. So that's one thing. Everybody's okay with this? Yeah? Let's move on to the next one, and then I want to talk about the graph of the function. That's when things get funky and pretty. I like the funky and prettiness of it. So now, here, do you guys want to, one other thing that I want to say, I forgot to talk about range. Bring it back. This page. What do you guys think the range of this thing is? What are the outputs that you're expecting out of this? Are you expecting any negative number? No. Can you expect 0? I can expect 0. I can plug in x equal to 1 and y equal to 0, and I get 0. There are multiple points that has everything on the boundary. Right? Can I get any positive number? Yes, so the range is 0 and infinity. That's the domain, that's the range. You can also write the domain in the format that I wrote before. I just didn't leave any space for myself. Domain also can be written as this. X and y such that x squared plus y squared minus 1 is bigger than or equal to 0. And the range is this. That are the same. One other thing that I want to say is that this function is a composite function. Funnily enough, the outer function is a function of one variable. The inner function is a function of two variables. right? I can write this as h of x equal to square root of x, and g of x and y equal to x squared plus y squared minus 1. Composite them together, it's still going to be a function of two variables. Talk to each other for 30 seconds. I think you guys need a little break. 30 seconds, go. Do you want to ask me questions? Ask questions. No? We're good? Was okay? Back? You okay? Also gives me a little chance to look at your faces, because if I don't look at your faces, I never can figure out your names. Ever. Okay, can I start again? Ready? Let's start back again. With that story that I told you, is this a composite function also? Is this a composite function? What is h of x and y? What is g of x? H of x, g of x looks like the outer function. It's a reciprocal, right? 1 over x. What's the inner function? Exactly. Right? So the composite of the two of them also would work. Now let's go back. What is the domain of this function? When is this function? What value can I not plug in? 0 for the denominator, right? So when the denominator is 0, it's not good. So I want the denominator not be 0. The reason this picture is here is because it's very difficult to draw this with pen. With pencil, you can do it. You can draw a big filled out rectangle, then basically erase a line out of it. Because what is this? This is just x plus y minus 1 equal to 0 is a line. And you are excluding it. Excluding a line. So everything but that line is the domain. So I can write the domain as x and y such that x plus y minus 1 is not 0. Right, fair? And that's the shape. I'm not drawing it because it needs a pencil. The pen is not good. Now, my question is, can you guys tell me what the range of this thing is? What's that? There will be a gap. How do you know? Because of that. Do you guys know this one has a gap? Where's the gap for that one? 0. So because this is GOH of x and y, the gap is going to be, range is negative infinity and 0, union 0 and infinity. Okay, one more quick one, and then I want to go to the graph, because graph is the fun part. Now, here, what is not in the domain? Y minus x squared less than equal to 0 is bad. So domain is x and y domain, x and y, such that y minus x squared is bigger than 0, strictly bigger, no equal sign. When I draw this, boundary is y minus x squared equal to 0. Is y minus x squared the boundary included in the solution? No. Why is it not included? ln of 0 is undefined. This is not equal sign. Not equal. Right? So this boundary not included. Draw the boundary. It's a parabola. Give me a test point. 1 and 0 is here, right? Plug in 1 and 0. For x, 1. For y, 0. Is it satisfying? No, 0 minus 1 is negative, so it's not satisfying. So the test point, bad. Therefore, you can check another point too, like 0 and 1, right there, and see that that's the answer. So imagine it also. Imagining it is important. Now, what is the range of this function? What is the outer function here? ln. What's the range of ln? It goes whoosh. Do you guys remember? Draw it in a negative infinity to infinity, right? Range, because natural log is whoosh. Why is it whoosh? I don't know. That's the noise that I like. So let's go to graph of a function. So what is the graph of a function? Look at this. You have a domain. Look at this floor over here. That's the domain of my function. When you plug in one point in the domain, you get a z-value. So if I give you a z-value for each point, there is a point in the xy z in the 3D. Another point here, another point. So it makes a surface. So graph of a function becomes a surface. So it's all x, y, z such that f of x and y is equal to z. Can I show you a picture before you go? So we're still in section 14.1. Then I'm going to go back today to section 12.7. So they're a little out of order because 12.7 is more related to 14.2. Now, we start with the graph of we talked about functions of two variables. And we talked about domain and range last time. Here are the examples that we did last time. We talked about domain and range, and we talked about these examples. I'm going to bring back these examples today, and I want to graph these three examples. That's why I still have them over here. So last thing that I talked about was graph of a function. What is a graph of a function? The set of all values, x, y, graph of a function f from domain D, subset of R2 to R, is all the points x, y, z in what? In R3, such that z is equal to f of x and y. So take a point in R2, x and y, embed the R2 as a subset of R3. What is embedding? Meaning that you put the z equal to 0. That's when R2 becomes a subset of R3. Right down here. This is R2. XY plane is R2. XY plane, R2. Question? There we go. Okay. Now it's fixed. So xy plane is R2. And what I'm saying is that for every point in R2, you find a z value using f. And so that z becomes a point in R3. Collect all those points together, it forms a surface. So this surface is the graph of f. Questions? Are we good with this? Okay. So let's do some examples. Do you guys remember I did this? That's this one, example 1. This one is example 2. Can you see it? And that one is example 3. Last time. Now, for those examples, I started it last time. Let's talk about it a little bit more. When I'm looking at that, it's all these sets, x, y, z, such that this is true. Graph is z equal to square root of x squared plus y squared minus 1. It's a surface. Do you guys know that? Do you know that surface? What is that? It's a hyperboloid of what? How many sheets? It's a 1 sheet because I can actually put in z equal to 0 and get something out of it. My question is, that doesn't look like that. What's wrong here? It's just a cut in half. See, if there was a plus and minus in here, it wouldn't be a function. If there was a plus and minus here, not a function. Right? But it's actually, if I make it z bigger than 0, which is this situation, this is a function. This is only plus. And it's just the upper half of it. So just the upper was. The lower waist is not. The upper waist is. It looks like a waist, right? It's just. Okay. That's the story. Now, I want you to notice this. This is a cool part. When I turn this around and I put, do you see which was the z-axis? The blue is the z-axis. I'm putting the blue into my nose. I'm looking from the above. Can you see this shape? Compare this shape to that. How do they compare? They're the same thing. If I'm looking from the above, the shadow of the graph on xy plane is your domain. Shadow of the graph on the xy plane is the domain. It could be the projection, not entirely shadow, because it could be under the xy plane and still make a shadow. Right? So from looking from the above is that story. Now, here we don't have a whole lot of stories. I just want to do the same thing that I did for the last one. Because I did this last time, but it was very quick. Oh, look at this. Compared to that. Again, the domain you can see from the graph, directly from the graph. Put the z-axis where? To your nose. Point the z-axis to your nose. And here again. And I make it turn so x would be the horizontal. What does this remind you? That one. You can see the domain from there. Right? And the range is just slice it in z equal to constant direction. It tells you if you can slice in a z equal to constant direction, then you have that value as an output, that z value as an output. Questions so far? Turn it off. Did that blow your mind away? I think it's the coolest thing ever. I might be a little dork, but that's okay. So now, so that was fun. We looked at a bunch of graphs, right? But all we did so far is z equal to f of x and y, function of two variables. What if I have functions of more than two variables, right? So what if, let's say w equal to f of x and y and z, or xn plus 1 equal to f of x1, x2, all the way to x and xn. Right? How many inputs here? 3 inputs. So this is f from D subset of R3 to R. And this one is f from R, I should have called this G, R to power n to R, n inputs. In these cases, again, the set of all inputs is the domain, all possible. The set of all possible outputs is the range, right? The only little problem that appears, unless you're very, I don't know, clever, there are clever ways of graphing this. But remember, when I had function of two variables, where did the graph live? Was it R2? Domain was in R2. What dimension did the graph have? What dimension did the graph live in? 3. So if I have 3 inputs and an output, where does the graph of this one live? R4, right? 4 dimension. And this one in Rn plus 1, right? So the graphing becomes a problem. So what do? We introduce level curves and contour maps. And so the next thing that I'm going to talk about, I start level curve with that type of functions, then I end up with this type of function. Fair game? So we are going to use the level things. Questions so far? Are we doing okay? So first of all, I want to give you a definition. Level curve of a function z equal to f of x and y is L sub k of f equal to all the points in the domain such that their z value is equal to k. This is a constant. So you may say like L2 of f. That is basically you're plugging in for z, you're plugging in k, z equal to 2. It's a cross section. This is a cross section in direction z equal to k. The only difference is with cross sections, you have them in 3D. With level curves, we typically put all the level curves in XY plane. With level curves, we keep them in XY plane. In the domain. It could be in higher dimension, the domain could be R2, or R3, R4, or so on and so forth. Now, you know, oh, I didn't say contour map. So contour map, a contour map is a collection of several level curves. Level things or level curves. So you have them all together. Here's an example. Do you guys know what this is? So what do these lines tell you? It tells me, hold on. Do you see that? That tells you the height, that tells you the altitude. So is this higher or is that one higher? This one is higher. Okay. Let me get a bigger one. I have a big one, I'll pass it along. Okay. Say z value here is 4, z value here is 6. Can you guys see this? 7, 8. Where do you think is the top of the mountain here? My watch or my other hand? Watch, right? So over here, where is the bottom of the valley? It's just decreasing over here, right? But then these two are of the same altitude and so on. Does anybody want to look at this? I can pass it along. No? So you guys kind of imagine I'm going up like this and I'm going up like this. Can you tell? Does my hand motion make sense? So it's you imagine from a 2D to a 3D. The next step, I'm going to give you an example in 2D entirely, solve it. But the biggest reason is then we want to talk about 3D. Again, sometimes this does a better job than drawing a surface in 2D. Do you guys want to do an old eye clicker? Are you getting bored? Let's do an old eye clicker, and then I do an example. If you want to pass it along, pass it along. Do this one. That's one that I missed. It's unrelated to this material, but I just have more to say, so I have to kind of stop you guys for a minute. What do you guys think? Which one is the answer? Michael, you're that way, I'm this way? So what is the direction? Oh, this is this one actually is related to your quiz right now, today or tomorrow. So which one is the direction vector? It tells you. Okay. So any vector in that direction or the opposite, exact opposite direction, you can scale it. Should be a direction vector. And you have a point. How do you write the equation of the line? This is which of these three sets of equations describe the line through points? Oh, I'm sorry, there is a typo in there. It's point, not points. Point. And there's a direction vector. Are we good? Everybody's good? Everyone? Can I stop this? So which one did you choose? Yeah. No. Yes. Okay, I'm counting down. 4, 3, 2, 1, 0. Oh, there's a big division. Let's throw this one away. Do you see another one of these? For those who did A, do you see another one of those? Yes or no? I'm running it back. I'm not grading that. Well, that was a little bad. Do it again. Four, 3. Is everybody doing this? 2, 1. What did you answer? Well, okay, I had 180. What happened? Come on, faster. Okay. 1/2, 0.25, 0. Somebody hasn't responded. You can contact me. I can look at your past responses. Come on. There we go. So one more. Since I started, I want to do one more. Do that one. This should be a quick one. How many options do you have? Not many, 2. Very quickly down to 2. Out of those 2, one is very obviously unacceptable. You can, so how do you do that? You say n times x minus, n dot x minus 1, y minus 2, and z minus 3. So basically,
is it the first thing?
So you have to have the normal vector. So it's 1 times x minus 1 plus 2 times z minus 3. What's the answer? Okay. Some of it I want you to answer very quickly. This is one of them. Are we ready? Yes? Countdown. 4, 3, 2, 1, 0. That's the answer. So, back to 1.4. Sometimes I have to keep you busy, otherwise, oh, thank you. So I'm going to do, again, contour maps, the level curves are interesting, especially for higher dimension. they're still useful because you already knew this. So it's useful, right? And you can tell which way the hill is, which way the valley is, right? So let's try to do a contour map for this one. It tells you the K. It's wanting you to find L0 of F, which is basically all the x and y, such that f of x and y is equal to 0, right? What is that? That's just this curve. Actually, that is not just one curve. What is that? X squared equal to y squared, x equal to plus minus y. There are two lines, right? So I'm going to draw that. One line, x equal to y. This is L0. X equal to negative y, or y equal to negative, again, L0. Now let's do one more level curve. L1 of f. What is L1? Set this equal to 1. Fair game? Everybody follows that much. So when I'm setting that equal to 1, what kind of a hyperbola is this? Opens this way or opens this way? It opens up. Are we sure? So if I set y equal to 0, I have x-intercepts. So it opens this way. I don't have y-intercept. I can't put x equal to 0, right? So if I set y equal to 0, I have x-intercepts. X-intercepts 1 and negative 1. Everybody agrees? So it looks like that. These two are L1. Now, what about L2 of f? L negative 1. Sorry, L negative 1 of f. Then if I set, this is what you're solving, then I'm checking. This is what you're solving, I'm checking. Y equal to 0, is there an x-intercept? No x-intercept. Is there a y-intercept? Y-intercepts exist. And that's 1 and negative 1. L negative 1, L negative 1. It turns out that you can solve it. I don't need to do all of them. Then L2 is going to be this way. And L negative 2 is going to be this way. So can you guys tell me, if I'm going this way, what is happening? Z direction. Hill or valley? L1 then L2. Is Z increasing? Z is increasing because it's L1 then L2 as I'm going this way. It's like this coming up. That way going up, right? This direction, Z increasing. And also that direction. How about that direction? It's going down, right? It's Z goes to negative 1, then negative 2. So this way, Z is decreasing, and that way. That's why it makes a saddle point. Because on the x-axis, if you're getting away from origin, here's the x-axis. Here's the origin. What happens to the height? Increases, right? Here's the y-axis. What happens to height? Decreases. So that's why the saddle point. It's saddle, one way goes down, the other way goes up. Right? The other way of explaining it. Fair game? You guys are okay still? Now, fun part. Yes. And so the next part is, let's talk about the function of three variables. Let's say I have a function of three variables, f of x and y and z. Let me go to the page. Right? I have a function of three variables that is f of x and y and z equal to x squared plus y squared plus z squared. You guys tell me what is level 0 of f. Can you tell me? What am I supposed to set to equal to z, 0? The output. So I get x squared plus y squared plus z squared equal to 0. Do you guys know what this shape is? It's just a point, right? It's just a point. Point 0, 0, 0. Fair game? Now, ask me another level thing, level set. 4, L4 of f. What am I setting equal to 4? The output. So what do I get? I get a sphere. What is the radius of the sphere? Radius 2. What is the center? 0, 0, 0. Can I find L negative? No. But if I set bigger and bigger k, does the sphere get bigger or smaller? Bigger, right? That's the... And that's the picture. So what is R3 for f? Are these the graph of f? What are these 2f? I'm not going to go ahead until all of you answer. What are these 2f? That's a contour map. These are the level sets. R3 is the domain of f. R3 is the domain. Level sets. Okay. So tell me, this one says x squared plus y squared equal to 9. What is the W for the blue sphere? What is the output of the function for blue sphere? 9. Did everybody get that? Question. What is the output for the purple sphere? 1. Now let's see. Let's do one more fun one, and then maybe a few eye clickers. So here I have this function. It's asking me to find level curve equal to 1. So what would that be? It's x to the 4th over 4 plus y squared divided by 2 minus z squared equal to 1. What shape is that? That if I set z equal to 0, I get something. So this is hyperboloid of 1 sheet. I need more space. Then it said L0, so I said W equal to 0. What shape is that? Are we good with that? Cone. Then x to the 4th over 4, y squared divided by 2z squared equal to negative 1, because negative 1 goes in here, and that's a hyperboloid of 2 sheets. So the contour map looks like this, basically, for this function. Turns out, we're not making this up. This actually is important in part of the physics. Maybe not the immediate physics you take, but higher up. It's actually an important function. And it tells you. So you guys do one. So what do contour maps tell me? The contour map tells me where the output of the function is what value in the domain. So it gives me points in the domain that with the value of the function, the output value of the function. Gives me height, gives me so contour maps tells you level sets, and each level set tells you the points in the domain that give you the constant value for the function. The output of function is constant. So you can think about it like, we're going to talk about it again, but we can think about that level set. Think about temperature. So temperature of the room, if you look at the surface, level surface, and the level surface tells you temperature of this level surface is so and so. But then this level surface is another one. Temperature function, right? We're good? All set? Ask if you, all set? Friends? All good? All good, okay. I'm trying to also look at your faces and remember some of it. It's like an eventual thing, but you have to give me some time. Okay, so what are the level sets for, what does the level set for this shape look like? You set the z equal to constant. What shape are you expecting? Parabolas. 4, 3, 2, 1, 0. Oh. Okay, one more. Do this one fast. You have to decide, I think, for this one. You have to decide about what shape does it give you? Lines. What do I need to know about the lines? Slope. Hold on. So you're setting 4x minus 3y equal to a constant. Solve for y to find the slope. Right? Find the slope in there. Is it positive or negative? What's the slope? 4 over 3. What is the slope of each line? What is the slope of each line? Slope of each line? Positive. What's the number? 4/3. Okay. Counting down. 4, 3, 2, 2, faster. 2, 1.5, faster. And 0. Yes, positive. That's correct. Okay, you guys are ready? Every time I say ready, like a little spike goes through your spine, like a little buzz. Like, oh, that's bad. What does she want? No? Okay. With this section, I'm starting 12.7. Are you guys ready for 12.7? You be ready? I have 12 minutes, Andrew. Okay. Do 10-second talk to your friend. I said do 10-second talk to your friend. He goes, ruffles all the friend's hair.